Hey guys, welcome back to Jyoti classes. So in the last class we have stopped till the uncertainty formula, and today we will be continuing the few more formulas on uncertainty. So we have to remember that for the real wave function, see, we need not to find the momentum, the uncertainty of the momentum. Directly remember that for the real wave function, the momentum is always 0. Okay, the expectation value of momentum is always 0, and the expectation value of momentum is written as minus I h cut dou by dou x. Okay, this is the hint for the momentum for expectation value. Okay, if the given wave function xi is equal to a xi1 plus b xi2, then how will you write the probability? In the last we have seen the expression something called E1 P1 plus E2 P2 for the expectation energy for nth state, that is summation of n En Pn. How will you find this P1 and P2? To find P1 and P2, you have to directly take the coefficient whole square. For P1 state, modulus of a square divided by modulus of a square plus modulus of b square. Similarly, for P2, modulus of p square divided by mod of a square plus mod of b square. Okay, and here I have written few of the hint to find the expectation value of position and momentum. To know this, see, for a given wave function, what we have to do, we have to compare the given wave function with the plane wave, that is xi is equal to a e to the power of I k x, that is equal to a e to the power of I p x by h cut. You have to directly compare the value of px to get the expectation value of x, to get the expectation value of momentum. That is, if this was the given plane wave equation and this is the expression given in the question, that is xi is equal to n exponential of minus x square by a square exponential of I k x. In place of p we have k here. Then directly I will say that expectation value of p is equal to k. Okay, this is the way to find the expectation value of momentum. We have to directly compare the given wave function with the plane wave equation to find the momentum. You have to remember this. Okay, now to find the expectation value of position, what you have to do is you should know the Gaussian wave function. Now using the Gaussian wave function, comparing with the normal given wave function, you can directly get the value for expectation of position. Okay, that is xi of g is nothing but the wave function for the Gaussian surface. It is 1 by 2 root of 2 pi sigma square exponential of minus of x minus expectation of x the whole square divided by 2 sigma square, where sigma is the variance. Okay, now you have to compare for the given xi with respect to the Gaussian wave function to get the expectation value of xi. Okay, if remember this, if my given wave function is something like e to the power of minus x square divided by a square into exponential of ikx was my given wave function. Now I have to compare this with respect to this exponential of Gaussian function. Here x I have already known and the expectation of x is missing in the given wave function expression. Then it clearly shows that for the given wave function the position is 0. The expectation of the position is equal to 0. Now just make a note of this formula if you are understanding. Okay, if not also, when we are going to solve the problems, we will be recap this formula once again and see what is the expectation of momentum and position. Okay, next, coming back to harmonic oscillator, and based on the harmonic oscillator, few of the formulas we should know. Directly remember these formulas. Okay, first thing, for an isotropic harmonic oscillator, the potential well V is equal to half m omega square x square. For 2-dimensional, that is potential is equal to 1 by 2m omega square x square plus y square. Here we know that the value of omega is root of k by m. And for isotropic harmonic oscillator, for 3D potential well, it is V is equal to half m omega square x square plus y square plus z square. Okay, these are the potential values for the isotropic harmonic oscillator. Okay, now moving down to the potential for the anisotropic harmonic oscillator. For anisotropic oscillator, we have to write the potential for the individual value and then we have to add it on. See, whereas in isotropic we have directly written x square plus y square for the 2D potential well. Here what I will do is I will take the parameter for x component separate and the y component separate. That is V is equal to half m omega x square plus half m omega y square. This is the potential. Similarly, if it was a 3D anisotropic harmonic oscillator, then I will directly write half m omega x square x square plus half m omega y square, the z component, that is half of m omega z square. Okay, remember this. Now the energy expression is given by, for 1-dimensional, it is En is equal to n plus half h cut omega, where n takes the value from 0, 1, 2, 3, so on up to. Okay, for 2D, it is nx plus half h cut omega x. This is for isotropic and these are for anisotropic. Okay, remember this. Now for 2D, it is nx plus half h cut omega x plus ny plus half h cut omega y. If omega x is equal to omega y, then En is equal to nx plus ny plus 1 into h cut omega. Similarly, for 3-dimensional case, nx plus half, ny plus half, nz plus half with omega x, omega y and omega z. Okay, next, if these 3 parameter omega x, omega y and omega z are equal, then the energy expression will become nx plus ny plus nz plus 3 by 2 h cut omega. Okay, these are the energy and potential values for isotropic harmonic oscillator and anisotropic harmonic oscillator, potential and energy expressions. Now we have a small term called as degeneracy. They will ask us to find the degeneracy of a given energy levels directly. So what is degeneracy? Simply remember that having the same energy values for different energy levels, having the same values for different energy levels. What I mean here? See, if I take the ground state, like if I say n is equal to 0 state and n is equal to 1 state and n is equal to 2 state. For this I am getting something as 6 pi square h cut square divided by 2 ml square, and here also I am getting the 6 pi square h cut square divided by 2 ml square. For the state n is equal to 0 and for n is equal to 1, I am getting the energy value as same. Then I can say the degeneracy is 2 for the given system. Okay, this is called degeneracy. For degeneracy calculation, we have direct formula. For 2D state, G is equal to n plus half. For how many, for n, which nth level they are asking, directly get the value. If they are asking, saying the third state of energy level, third state of energy level is what? That is n is equal to 0, n is equal to 1, n is equal to 2. Here n is equal to 2 means 2 plus 1 is equal to 3. Then I will say the degeneracy is 3. Similarly, for 3D state, that is G is equal to half n plus 1 into n plus 2 directly. Okay, see here I have written one of the example, that is for first excited state energy expression I have directly written. See, this is not the full question. Here omega x, omega y and omega z are equal. If these three are equal, we know that this is the formula, directly substituting the formula here. Here for the different state, that is 1 0 0, for 0 1 0 or 0 0 1, these are the three different values for any of the given energy state, that is 5 by 2 h cut omega. Now I can say that for this energy 5 by 2 h cut omega, my degeneracy, that is G is equal to 3. Okay, you have to remember this. So let this much be for this class, followed by commutator bracket in the next class. Thank you guys.